Well, before he starts, I'd better introduce him. He came up earlier and said he was a first-time member visiting. So welcome, Paul. But Paul Hattam will be giving a talk on the difference between Dicots and monocots, or monocots versus Dicots. There's two different branches, angiosperms and flowering plants. So I'll be very interested on this. Over to you, Paul.
Thank you, Peter. So I come from a background of horticulture and healthcare. And this is a talk I gave to the technology and science group. And so one of my the first things I learnt in horticulture was the difference between dicots and monocots. And tonight I'll be giving just a very brief breakdown of it. Otherwise, I'd be here all night. So, dicotyledons and monocotyledons come from a group called angiosperms, and that's the pneumoculture term for any plant that produces flowers, basically. Basically, the ones we like to put in our gardens. And I'll be talking about the physical differences between the two. And while these terms may look intimidating, I promise you by the end of it, you'll at least be able to pick the difference between the two. Now, I'm going to go through the life cycle of a plant because it's much easier to talk about the physical differences. And the first stop we're going to do on our tour is at the seed. Now, if I was able to cut a seed in half, this is what we'd find. Now, the one on the first one here is a dicot, and the other one's a monocot. I won't go into the differences with seeds, because that's a whole other subject together, but I am going to go over some of the terms, because they are going to pop up a little bit later on. So the first one is the angiosperm, and that's basically a reservoir for the plant to grow. A bit like a chicken egg, with the yolk inside it. This is what gives the plant the energy to start producing its first leaves and its first root structure. The next one coming along is the cotyledon. Now, this is when you see a plant, I'm sure there's gardeners among us that have done seeds, you see those first little leaves come up, they're actually called cotyledons, and they're the very first leaves that come up. Followed by that is the hydrocotyledon. That's what it is attached to. That is the stem that will grow up and where the leaves attach from. The next part coming along is the radicle, and that is actually what becomes the root structure of the plant. And I will explain, these will all come back around as I go through the slides. So first off, the first thing you'll see when a plant starts to grow is the actual leaves. Now, this leaf here is a monocot. Monocots are basically anything that's a grass. So your lawn, lilies, palms, they're all monocots, basically grasses. And the first one, the really easiest way to tell the difference is by these lines here. These lines are actually veins. These veins carry the nutrients and water for the plant to grow, much like the human body. The blood vessels that carry the oxygen and nutrients for our cells does exactly the same thing in plants. And they're always in parallel. They never, ever meet. The other one there is a dicot, and it branches out from the stem of the leaf and then branches out into the leaf. Much like the veins in the human body, it spreads out all among the leaf. Monocot leaves always tend to be long lance-like structures. They do different, some palms and stuff, but mainly they're always long and thin. Dicots come in all types of shapes. From the modified spikes of a cacti are actually leaves. There's an interesting fact, might come up in pub trivia. Or many lobed leaves are like on an oak tree. I could be here all night talking about it. However, I'll leave that for another time. Now, the stem that supports a plant, if we were to slice that and put it under a microscope, we could see much bigger differences in the dicots and monocots. So the monocot the stem tends to be, these little dots here are actually the vessels that carry the nutrients. You can see they're quite scattered throughout the monocot. And, oh, look, some action going on over there. Whereas in dicots, if you're actually, you can actually see the vascular bundles are actually in a row, in a nice circular structure. So speaking a little bit about the stems, you've got the epidermis, much like the skin on the human body. It protects the plant from insects, disease, keeps them waterproof too. Then as we go into the plant, we've got the vascular bundles. Going into it a little bit further, there's actually a ring in between on the dicots, the cambium. That's where all the new cells grow from, and I'll explain a little bit about that in a second. And then we've got the pith. Now the pith is where all, as the stem grows bigger on a dicot plant, this fills up with dead cells. They are actually, all the nutrients is actually taken out. This is where all the dead cells come. This is what makes the plants, like trees, able to grow really tall, because this actually solidifies and keeps the plant nice and strong. This is where wood comes from. Many people like to make furniture out of it. My favourite thing is to release that store energy in a nice fire. So the cambium is only found in dicots, where these new cells come from. And one of the big differences in dicots is an area called the procambium. It's just outside that cambium area, and that grows the bark. Only dicots have this. This is another protective measure that dicots have against invaders. Also good for starting fires, one of my favourite pastimes. I know I'm not a pyromaniac. Moving on, the root structures also. So as that radical goes down into the ground, dicots tend to make this taproot. It's one big central root, and all the other roots spread out from there. This gives, much like the pith and the bark structure in dicots, gives them an immense amount of structure. We like to say that the top of the plant, like if you imagine a big tree, its root structure will basically be mirrored down below. That's why, you know, if you ever have to move a tree, it's really difficult, because if you disturb any of that root structure, you can actually quite easily kill it. Also, if you've ever, any avid gardeners down there know, especially dandelions are an absolute prick to remove. You can spend hours, and 9 times out of 10 you'll rip the top of it off, and then you'll know a couple of weeks later it's going to grow back. And that's all because of this taproot structure. Monocots, on the other hand, actually tend to produce more fibrous root structures. This is why they don't tend to grow very tall like dicots. They just don't have the root structure to support it. But they are able to spread out, and they actually are much hardier because of that. It's why we have lawns, because they create like a nice mat structure. The other thing about dicots is their roots actually grow much like branches and stems. They actually grow out in girth. Monocots don't actually do that. So once a plant has matured, it's come from a seedling to a mature plant, it actually wants to be, like all living things, wants to continue its species and produce a new generation. Flowers, the easiest way to tell the difference between the two is you can divide them. So monocots can be divided by 3. So, and dicots can be divided by either 4 or 5. So if you like to play a nice game of love me not, if you can pick all the petals off it and you can divide it by 3, you've got yourself a monocot. If you can pick off all the petals and you can divide it by 4 or 5, you actually have got a dicot. That's not quite. That was the end of it. thought I had a bit more slides than that. I thought I had some pictures that should have gone up. There they are. They didn't actually. My apologies for that. Oh, now it's going to start from the start, isn't it? Thank you for that. Nope. I am just going to scroll through it. These are actually some excellent pictures provided by Danny, who's another member of our Science and Tech group. She did a lovely presentation on microscopes, and she was lovely enough to give me some pictures. This is actually what you'd see if you would actually look at under a microscope. This is actually a monocot. You can actually see these big, large areas. These are actually the vascular bundles. This is also another really good example. If you were to looking under a microscope, it's not as these haven't been dyed at all. Usually when you do microscope slides, they're dyed to show these more details, but this is just another really good example. You can see the vascular bundles around the outside, which might suggest it's a dicot, but you can actually see that it's because it's spread throughout the stem. You can actually see that this is actually a monocot. This is a really good example of a dicot. You can actually see that nice circle structure, the vascular bundles in the middle, right in the middle there's the pith, and then outside is those new cells growing out. Again, just a really good example. Another good trivia question, those rings that grow in trees are actually the older cells moving inwards, and really good for telling you the age of a tree. Again, another really good example. These are the ones that obviously have been dyed, and these make much better examples of showing you the internal structure. Again, Danny did an amazing job getting some of these slides. And then we're coming up to some seeds. Can't remember off the top of my head what this one was, but you can, this is just, you know, it's fascinating to me that a seed can contain all the bits and bobs you need to grow a plant. You know, we think we're pretty impressive by computers with CPUs that have all types of different functions, yet a living thing can sit in a tiny little seed. I find that absolutely fascinating. Now this is a typical grass seed. Most grass seeds tend to be fairly fleshy and produce singular seeds. You see this in things like wheat and rye. Dicots tend to produce all kinds of different types of seeds, from seed pods and all types. And I've got another really good example of that coming up. I actually know this is a strawberry seed that Danny took under. She's got a whole process behind it, and it was really interesting to have a look at seeds under the microscope. I know I can barely see it from the seed packets I get from Bunnings. To see them up close was really interesting. So, thank you all. I hope you've learnt something about monocots and dicots. That's it. Yeah, were there any questions?
Just wait for the mic.
Yeah, certainly.
I was saying, how do four-leaf clovers fit into the scheme? Because they're divisible by 4.
They're actually leaves. They're actually not
they're
a
not
flower.
flowers.
Yeah,
Got
yeah.
it.
Yeah, that's actually a genetic mutation. They're actually fairly rare, but now they've been bred, you can actually, you know, say you're pretty lucky to find one. So, yeah, any other questions? Any general gardening questions?
Well, can I ask a question? What's the difference between a seed and a bulb?
A seed and a bulb. It's just the way they reproduce. So a seed is generally too genetic. So when it gets pollinated, the bees carry along actual sperm. They'll travel down into the ovaries, and those ovaries are what actually produce the seed. So they're actually genetically different. A bulb will actually produce a clone of itself. So genetically, they are very much the same.
We've got frangipani in flower right now, and I thought they were more of a summertime thing. Is this a climate change effect, do you think?
Yeah, it's really interesting. I remember a couple of years ago, there was it was in the local, back down where I grew up, they were talking about, it was actually talking about how plants were flowering in winter because we had such a mild winter. Plants are generally affected by temperature, and so when they think it's nice and warm, they go, oh, great, let's start putting flowers out. And then 3 weeks later, they found out they wasted all this energy because the next day, in the next 3 months, it's really cold. Climate change is a real issue for plants because they generally tend to work on a pretty good cycle of, yep, I will grow at this time, I will produce flowers at this time, I will drop all those flowers and leaves to conserve energy for the colder periods, and then I'll move on. So these periods of warm and cold are a bit frightening for people who are trying to grow produce, really.
No further questions? All your flowers are growing, your vegetables are growing, the lawn's growing, the moss is growing in the lawn. You're all quite happy with your gardens. I trigger a question, did I, John?
Thanks. There's some distinction between pine trees as a more ancient structure and the eucalypts, for example, as a modern flowering plant. Does that cut across the monocot, dicot, or?
Yeah, I was going to mention pine trees are actually a whole different category. The actual flowers they produce and are like modern flower types. Pneumoculture is something that annoys a lot of horticulturalists because somebody finds a new physical difference with a plant, so they tend to like to pick up that plant and shift it, and then you go to look up that plant and you can't find it anymore because someone's given it a new classification. Pine trees, because of the cone-like structures that they produce, don't fall into the angiosperms. And eucalyptuses do, and they get changed all the time. Sometimes they'll be called wattles next, or depends what a university student tends to do at the time. Thank you.
No further questions? They must all have their horticultural organised there, Paul. And thank you very much. It's a slight difference to our rams and mouses and all that sort of thing, but thanks very much, Paul.
Thank you all.